So next lesson of robot programming, we start from where we left it last time. We ended up with a gigantic or a piece of software that was starting to become pretty big, and our goal is to split it and to make it manageable in individual files, and eventually splitting the headers from the CPP files. Okay, that's our goal, and then after we do that, we proceed and we will we will add the robot and sensor class or anything which will then implement our concrete simulator. Because what we have now is a skeleton. We have a class which is the word, which contains objects, still somehow, and that evolves these objects periodically by calling a tick function that represents an epoch that has passed, and a draw function was task for an object is to display himself in a given canvas. Okay? That's the game. Like, in order to proceed, what you find in the repository is a little bit of structure. I created a folder which is called Simulator Step by Step, where all the software that we have written last time is. And in Simulator Step by Step, you find the CMake list and a source folder. In the source, there is the coso.cpp, which was the thingy we wrote. And clearly, I had to edit CMake to specify that coso, the target coso, is generated by a source file which is located into the directory source relative to the CMake. So far, so good. Okay. Now we start polishing. That's the polishing, our task, which means splitting the files. We start from this blob, and then the very first thing that I would do is to generate a file which I will call simple geometry. Come on, let me put all the geometry things, which is point, int point, and pose. Pose? Where is pose? Well, there is pose somewhere. Yes, there is also pose. And pose into an own file. Now, before I do that, let me, how to say, introduce you to the keyword inline. The keyword inline can be put in front of a method of a class or in front of any arbitrary function, and this keyword instructs the compiler not to generate calling conventions for that function. If you declare an inline function, the inline function should be present in the header file, because no code is generated. That function becomes a macro, and a macro means it gets really expanded when you invoke it. And this is gonna save time. And typically you declare inline functions which are very small, that do not, clearly they cannot have recursion, obviously. That's what you do. Now, you pay a little bit in compilation time, but you gain in efficiency. And if you look at the code generated by this thingy over here, you might figure out that the code is very small and it's proportional to the time that the compiler will spend to create the activation record and whatever. There, the compiler. The time spent in the compiled code to execute the activation record. The compiler does nothing. The compiler only translates from C to machine code. Okay, so improperly I often say the compiler does. The compiler just generates code. Okay. In the next episode, the compiler will also execute something. But now, let the compiler generate code. Okay. So let's call it simple. I'm creating a new file. I call it simple geometry. It's an header only file, because now I will inline each of the functions that I'm using here. I go here. It's an header file, so it's a good practice to start an header file. It's a good. You do it. Dot. You start every header file with pragma once, which means that if you have multiple inclusions, this file will be included only once. Then I copy point. But I would like all these functions, I would like not to, I would like to declare all these functions in the header only. So I would like not to have a C++ file for this, because the point is a very small entity, and I want it to be treated as a macro. So I would write inline in front of each of these functions. Okay, this is a choice. Clear? Then we have int point. Int point has been copied. Clear? Easy, easy. And also here, inline. You don't write inline in the constructor, because it's expanded in the body. I mean, in general, I have to tell you a truth. If you write the definition of a function into the class, this function is a candidate to be inlined automatically. Okay? The compiler tries to do the impossible when to optimize the things, and if it finds the definition, it tries to inline. As said, you pay that with an increased compilation time. Okay, as long as I copy these classes, I remove them from the coso.cpp because I don't want to have mess, and pause. Pause, and also pause inline everything. Only those? Yes, seems so. Then I have a bunch of operators, right? The streaming operators. I will copy also those, but there's one thing. Let me tell you that the streaming operator in the end has to do some expensive operation in the end, because it has to call the printf and it has to call library functions, first of all. So I might decide to put them in the header, or I might decide for these functions, and only these functions here, so this operator here, that's the one that prints a point, I might decide to put them into a CPP file, which I will call simple geometry CPP. Okay? Of course, I will require to have this definition of the functions, the declaration of the function in the header file. Okay, so let me open another file. I include the corresponding header, and I start moving the streaming operators. Delete this stuff from here because we don't need it any longer. Done. But at this point I couldn't call this. Okay, let's see what happens now, because we will have a compilation error. What happens now if I do something like that? I mean, now this is a pure header that we have made, and we have some functions in the CPP file. Okay, so clearly I assume I will have to compile simple geometry CPP. So I would have to say to CMake that there is a file which is called simple geometry CPP that contains the implementation of the stream, of the way to print the point. I have to tell it to the build system. So I will have to go to the CMake and add to the dependencies for the target coso simple geometry.cpp. I go to the CMake lists, source, put it here. I compile. New layer. Complaints. Oh, very first thing that on which the system complained is, man, when I'm trying to compile the class point, I do not find, let's see what it told me. Sorry, I'm very fast in looking at the error. It says sign was not declared. How to solve this? Math. We have to say, okay, yeah, I'm calling a function and the compiler is not aware of, so sinus somewhere. So I have to tell it to include the corresponding header file, which is in math. Math.h or cmath if you want to be compliant with C++. It's the same. Nah, come on, let's be alternative. Math. Hmm? Hmm? Ah. Alt-X compile. /bin. Okay, I'm fine, I'm super happy, but what is this OStream, no? And then now it tries to compile, because before the file started compiling simple geometry CPP. It included the header simple geometry.h, but then it finds this new thing which is called OStream, and it says, what is an OStream? So we will have to include the header file that contains the class, the definition, the declaration of OStream, okay, which is IOStream. I do it in the header file. Okay? Or I could do it also here. Normally the rule is to include the files only when you need them. So let's include it here. I mean, that's the strongest, I don't know if this is a hair dryer or what, but I mean, it's a helicopter, it's something insane. I mean, probably they have optimized the acoustics to convey into the A7. I mean, you might ask, Giorgio, why do you use sometimes the quotes and sometimes the angular brackets for including the files? The difference is that the angular brackets are normally referred, you use angular brackets when you refer to some external library or thing. You use the quotes when you refer to something which is in your own local folder or project. Let's see what happens. Andiamo. Complaining. Why complaining? Because these objects, the objects of OStream, the class OStream, is defined inside the namespace. The namespace is, I don't know, like a package of Java. It's a thing that contains other things, and you can have nested namespaces. So if you want just to use the classes of a namespace, you have to use the following statement using namespace standard. In this way, it's like you're telling the system to look, whenever you declare a type, it will try to look for this type either in the current namespace or also in the namespace standard. Okay? Alternatively, you could specify the namespace before every class, like std or string. Okay? Because these objects are declared inside the namespace of string. Like so, if I want, which one do you prefer, the using or the std? Using. It's more compact.
But if we make using namespace std, don't we lose some efficiency because of
No, we don't lose any efficiency because everything is resolved at compile time. Your colleague asks, don't we lose some efficiency? No, because everything is resolved at compile time. So that becomes an address later on, you don't care. What you lose is if you have two different two classes having the same name in two namespaces that you include, for which you declare the using, then the compiler might ask you, hey, which one do I take? You have to specify it explicitly with the std blah 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 blah. That's an ambiguity.
Prof, you said something about the quotes. I've got some errors about OpenCQ.
We will let me finish this and then we will heal it. Okay. Okay, now using ASS. Okay, now it's super fine. It went on the compilation, but then it starts complaining, hey man, I'm compiling COSO CPP. I don't find any match for the operator greater greater. Thank you. It's not declared. Imagine what happens when you compile COSO.cpp. We compile COSO.cpp. We have include simple geometry. Simple geometry only includes the class point, int point, and whatsoever, but it doesn't know anything about the streaming operator. Sono troppo distanti. No, non è che cioè... Ma perché non I'm streaming. Allora, so what happens when you include simple geometry? Let's look at simple geometry. We have point, we have int point, we have pose, but there's no position where we instructed the compiler about the existence of the streaming of the function of stream operator greater greater. Okay? So we have to do it. How do we do? Simple geometry.cpp. I'm a butcher, so there is a function, there is another function, and there is another function. Now I will have another error, right? If I compile this thing. Will I? Well, I don't know what is your stream, because when the compiler compiles this thing, look what happens in COSO.cpp. It includes all these nice things. It uses the namespace standard, but all these things are declared afterwards. So when it includes simple geometry.h, at this point it didn't yet include the header where IOStream is declared. So we can solve this by going to simple geometry.cpp and moving these two things into the header file. Now everything went well, and we start moving away the files. No, we start organizing the echo.
If I have a header file that is used by all my CPP file.
By only inside the CPP, so you don't expose any structure.
The other header files.
With the pragma, you.
It's normal to put the namespace and
The space
and the other libraries in the.
Allora, normally, like there are two different schools, no? There are the purists that never use, if they use a package, like your colleague asks, is it normal to use this, to have this aggressive usage of namespace? Like, because now we declare that we open the namespace in this immediately in the header file. So every class that will include point will also use the namespace standard, right? This might be a potential fault, like because maybe we are unaware of which are the namespace that we are using. So a good practice in this context, like, is to do this. You delete the using from the, to protect yourself, you delete the using from the header file, okay? You put the using in the CPP file, because in the CPP file you can do whatever you want. Is that clear? So in the CPP file you will have access to the classes as they are, and in the header file you use a fully qualified types for the streaming, for the whatever you're using. So you basically replace stream stream with okay. So what you do in the header file that you want to keep closed, so to say, you fully qualify the paths and the objects that you are declaring by specifying which namespace they belong. And in the CPP, that it's your own stuff that compiles on its own, you go in the shallow way. Clear? Do you understand the problem? If someone was including point, it was automatically using the namespace standard. But if I am using two libraries that both define a stream on two different namespaces, I might have a clash. And I want to be sure of which path directories I'm including. Let's say this way. Namespace can be seen as a folder, as a path directory. Then we will approach your problem, but I'm recording, so can we do it at the end of the lesson? Because
no, it was just only about, you said about the quotes.
Yes.
You said that if we have like a library or something that we have in the project, we use the quotes.
Yes.
But what about OpenCV? So
because CMake OpenCV, you can include it both this way and this way, right?
Yes, we did like this.
Yeah, I mean, okay. Before I said this thing about the headers, that where was it? Well, that if you use a quote, if you're referring to a project which is outside. When you use CMake, given that not every compiler is so picky in choosing, like in the discerning between the brackets, CMake makes it easy and allows you, like, the environment, the path directories that CMake inserts, the command line allows you to both use quotes and Angular. CMake generates makefiles. Makefiles contain compiler options. Compiler options contain folders and directories and whatsoever, what so forth. No, and CMake expands these in a way that you can use arbitrarily one or the other.
So it's like a compilation time we got?
Not a compilation time, it's the options of the compiler. So how do you specify to the compiler whether a library is internal or external, right? It doesn't know it. It just like needs to look for the header files. So if you type -I in the options of the compiler, this is a path that will be looked at with the Angular bracket. Okay? If you don't type anything, the default is the current directory. And with quotes, you like go forth and back with respect to the current directory. But with some compilation options, CMake alters this path and makes them even, I think. I mean, I don't care. If it doesn't work with the Angular, I put the column and that's it. Okay? But it's a convention. Okay, this compile. Now, let's proceed, because otherwise we will never rent, non affitteremo più. Now, let's split the word. Word and word item, they have to live in their own universe. Do you agree with me? Very good. And so, world, we start word H, pragma once. Oh. Ah. Clearly, I will have to include simple geometry, and then I will start moving the stuff. Using namespace standard, I decided not to use this namespace standard in this thing. Can we move this constant inside the class word? Makes a lot of sense. It's an object, it's a thing which is relative to the word. And then I do the butcher. I copy everything in the other file. Boom. Okay. And then I have to start separating header and CPP files of this class. Make sense? Pretty much. But I want to fix the includes before. So which includes do I need? OpenCV. Yes, I do need OpenCV, and also might potentially need IOStream, but IOStream is already included by simple geometry, so I just need these two things. Word.h. That's B. Correct? Fine. And then I copy everything into Word CPP. That will have to contain Word.h. I have two copies of the same thing. Now I can say safely. Okay. Now I can safely start deleting stuff from here. The constructor, I will leave it only in the header file, in the CPP file. These are inline functions, which I leave as they are. The function collide is a pretty beefy function, so I will leave it only in the CPP. So, blast it. Inside is another inline function. Let me move it on top just for cosmesis. Word to grid and grid to word, I think that they are small functions that will be extensively used. Do you agree? Moving from cell to word, they are very small. I will leave them inline. Which means I don't copy it, I don't differ. Load from image is beefy. Move away. Okay. Draw, even if it's not draw and timer tick. Okay, we will work on that. Draw also, I will leave it in the CPP because it will grow in a while. And did we call the function timer tick? Well, was it like in the word item we had a function which was called time tick. Okay, I will also write in the simulator a function which is time tick, because time tick of the simulator will have to call time tick for all the objects which are of the word. We'll have to call time tick for all the objects which are inside the word. Okay. dt is the time point. Agreed? And of course I will have to put it also on the other side. Now, a little bit of cosmesis again. Do you think it's proper to promote distract to an object which is a little bit more significant? Let's turn it into a class. Okay? Ready? It's very difficult. Done. The class has a bunch of public members. Now I will put in the class. You have to also in the struct, but the struct defaults to public, and the class defaults to private. In Java or in some other programming languages, we have to specify for every method whether it's freely accessible by anyone outside, or if it can be accessed only by member of the same class or by member of the derived class. The semantics is the same as in Java. So public, private, protected. You can also have it in the inheritance hierarchy. Right now in C++, you do this public column. This means that anything that follows is public. Then if you can put private, and then anything that follows private, protected, and so on. This is equivalent to put public in front of every of these things. Now everything is public without mercy. And let me put all the variables at the end for a reason of, cosmesis. Okay? Fine? Good? Nice. The word item also has virtual methods, so also word item will turn it into a class. And we default now we don't want to have any mess, so everything is public. We solve the problem one by one. And the variables, I move them at the end for cosmesis. Okay, now, I leave this recursive version of posing word. I don't like recursion. I like recursion, but I don't like recursion. Recursion is the less efficient thing you can do, unless it becomes tail recursion that the compiler optimizes. Normally, you could turn this, delete the recursion from this thing very easily, and we will do it in the CPP file. For now, I just say that this I don't want, this I'll put it in there. So anything I do will go into the CPP file. Okay? And now we have a much smaller and readable header file that, yeah, if it wasn't for these inline functions, we could have a grip of our library or of our classes in just like by looking at it. Okay? Clear? Now I have to go to the CPP. The time tick, I said it time tick. First word CPP. Now, this is blasted. This goes away. This goes away. These are all the variables. This is the constructor world. I have to qualify each of these functions. I have to say each of these functions, they belong to a class. So for each function, I will have to write what is the class to which it belongs. The inlines get blasted because they are defined in the header. Collides is a function of word. So again, word, inline. Word to grid, I declare them inline, I think, yes. Word to grid, grid to word, blast. Load from image, word. This is a function of word. This we don't need. Draw becomes word.draw. And this goes away. Easy. Yes?
Can we use, in this case, the namespace for words or not?
No, I mean, we could have a namespace for all of our system, and we will do it.
So that we can just remove the word.
No, because no, you can't, because in this same file we will have both two functions draw, one for word and one for object. How do you decide which one is which?
Yeah, I didn't understand this.
You have to, like now, once you are here, the compiler starts and say, oh, I find a nice, whatever, function word that has no arguments. To what does it belong?
Yeah.
You have to specify, because in the header file, you are here, you know that you are inside the class word, because you are inside the curly brackets. In the CPP files, you don't know that you are in the class word. You don't have a scope.
Yeah, I thought there was something like
No, you can't do it. But, fine. Let's work on word item. And then to be defined. And then we are ready. Hopefully everything will go well. We go to Coso. We blast anything that we have in here. Via, run. Okay. That's it. CMake files.
So in Coso we're only the main, right?
Yes, it will be the main. Coso is only the main.
We should include the word with H.
You're right. But I will not, so that we troubleshoot. So the goal is not to write the program without mistakes. The goal of this game is to encounter mistakes and to try to solve them. But yes, I take it. Yeah. It complains because it says, oh, you declare the word endl, a thing which is endl. Where was it? In word.h. Huh? Where are you? Default argument. This is another interesting error. It says, man, you have given me in the CPP file, you have given me a default argument, and I find a default argument also in the header file. You could make mess and assign two default arguments which are different, so the rule is that you put the default argument only in the header. Okay, so I will have to delete all default arguments here. See? Crying again. Now this CR, guess. CR is not defined. Why is not defined? Because CR is an output string which is a children or it belongs to the namespace standard. So either we put a using or we put std_char. Clear? No, yeah. Word is not declared. How comes? We have to include word. No. We are more or less where we were, but with manageable files. Okay? Very good. Let's test something. Let's go back a little bit to our class word, because we are a little bit buffers, word.cpp. Let's go to the class word and edit this method which is posing word. Posing word was calculating the position of an object in the word by composing the transform of the parent and the parent of the parent, and so from the root to the current object. Okay, by recursion. You could do it without recursion, but I want to leave it as a task for you. I mean, in the spoiler there is the solution, but don't look at the spoiler. Okay, it's very simple. It's a while loop that recurs backward and multiplies to the left instead of to the right. All right. What do we have? What do we want to do? We have the word, timer tick, items we clear. We have a number of items. Let us write for a second the function time tick and the function. We also need another thing. Let's call it add. Or even better, a function add, which will simply add or bool, I like it, bool, that will try to add the word item to the word, like which means that it will look for a certain free position in max items and will put the pointer, right? But we would like this function not to be called explicitly. We would like that when we create an object and we put it in the word, the object itself adds himself to the word. Is that clear? Yes? Okay, so let's write the add function first. Let me go into the CPP file. Or shall we be more elegant? Shall we completely delegate from the word the ownership of the objects? So we say in the word is not responsible of the memory management of the objects. Okay? Do you agree with me? So we could rewrite the function by having a different signature, word item ampersand. We pass a reference. Then the function will extract the pointer and it puts it into the pointer list. But that object is not responsibility to be managed by the staff. This is more clear for the user. It will understand, okay, I have to take care of this stuff. Like it? Me too. I'm losing control. Ampersand. What do we have to do? If smaller smaller than okay, what was the variable? Max items. the address of item. Easy. Okay, we could also handle holes in the vector, compact it, use more sophisticated structures, but let's move on, right? And then we would like to go in the constructor. This I have to move it on top because before there was the thing of the word class. It's not mandatory, but it's elegant.
I lost it, but why having one CPP file for Word and Word item? Why having one CPP file for Word and Word item? Or
one.
Why having one CPP file for Word and Word item?
We could have, like we could split them in two files.
Okay.
Your colleague asks, why do we have one CPP file for two classes? We can split them. I mean, if I feel like that it's too much code, I'm going to split them. I mean, normally in a proper project, you just try to divide the things and split the files. But these two are so entangled that your colleague asks, why didn't you split the word and word item? We could. But exercise, no? You can do it yourself. Okay, and the word item, it's a well-behaved thing, right? That if there is a word, if it has a word, it's just word add myself. Does it make sense? No? We would like to throw an exception to break our program if it doesn't work, the addition, no? Or we want to use the assert. Well, let's do this way. Want to use the assert? No, because the assert is going to be deleted at equals. Start this. And the same. If you might also decide to create an object out of the word, but in this case, it will be your responsibility to add it. Make sense? Okay. And if this is a way of crashing your program. You throw just an exception. The exception mechanism was born in CPP and migrated in Java. So the exceptions are more or less similar things, and the same concept. But you don't use exceptions. Exceptions are inefficient. I don't like it. We could do, I don't like it because I'm writing the same piece of code twice, right? So wouldn't it make sense to just like add the exception to the word? Bah, it's like these are. I'm never in peace when I code, like, you know. I'm always refactoring stuff. Copy the U and copy U. No, that was already copied, okay. If not, result, basta. That was it. Do we need anything else? No. Oh, good. We went through. All right, then let's go on and let's create a robot, which will be another class. It's reasonable to open a new CPP file, and header file, and to start writing the robot inside. I start with the CPP and then, you know, the usual dynamics. I create a class, include the word. The robot is an object of the word, don't you agree? So I will have to implement derivation. So I will have to derive from the word item, which I never remember. Control X3, Control XB, word.h. Okay. Word item, because I need to remember the constructor, public. Right? We like it? Good. Okay, what are the variables? Everything is public for now. What are the variables that we're going to put in the robot? The pose is already inherited by word item, so the robot has already a position, right? We might want to evolve the robot. We might want to say that the robot has a radius. Makes sense? It's a ball, it's a circle, right?
A vision radius, maybe.
No, that's a sensor.
Okay.
And the sensor sits on the robot. Colleagues has a vision radius. No, the robot is just a mobile base, just the wheels and the trailer. What else? Maybe if you want to control it, let me be a butcher now. I just put in the translational and the rotational velocity. TV, RB. And I initialize them to 0. Also, in terms, a robot can only be placed in the word. I wouldn't be, well, yeah, it's not actually true. We could decide to put a robot on another robot, like a carrier, no? But for now, oh, actually, that would be really cool with order. And that would work. But for now, why do I need to crop myself this way? Let's assume that a robot could be on another robot. You might have a ship carrier with a many little robot inside, no? And you might want to, if you move the carrier and you move the robots, then everything gets moved accordingly. I mean, I just have to defer to continue these constructors, potentially adding a radius. I clearly need the parameters of the base class. And I also need the radius. I assume that the radius of the robot cannot be changed while the robot is deployed. Makes sense, no? Unless you feed it a lot and then it becomes bigger. Then I have to call the base constructor, right? Equals. I have to call the base constructor because the word item requires something to be initialized. And radius equals radius. I could also do it in the initializer list, it's not a dump. Okay, that's it. And then we have to implement two functions, a draw and a timer tick. Let's start with the timer tick. Sorry, word.h, time tick takes a float, right? Okay. Void tick. Now, in implementing the DT, presumably I will have to evolve the position of my robot. Okay? based on the current translational and rotational velocity, assuming that they are executed for a time dt. Okay? Now, technically, the robot moves on a circle, because if I have a constant tangent velocity and a constant angular velocity, I could do a little bit of geometry to figure out how much the robot moves. Now, for a moment, just think, but let me simplify that brutally and saying that I have a differential drive robot that if I apply, so like the one with 2 wheels, right? That cannot, if I have a robot with 2 wheels, it cannot move sideways. So if I say translational velocity, it only moves along its x-axis, the front axis. Okay. Move that. And if I apply a rotational velocity, it only rotates on the spot. Okay. So if I want to calculate the next position from the origin, like I start in the origin and I execute a translational and a rotational velocity, this is an approximation. If you want, I can point you to a simplistic thing that calculates the things correctly, but at high integration rate, this is not a big problem. Okay, so we can calculate the next position of the robot, assuming it moves from the origin. Okay, integrating the translational and rotational velocity by a time dt. Okay, so along the x-axis, how much do I move? dt, so translational velocity times dt. Agreed? I'm moving along the x-axis. I'm oriented in the origin. Along the y-axis, how much I move? 0. How much do I rotate? Rotational velocity times dt. Times. Okay. Are we happy with that? More or less. But this is the local motion of my robot, assuming that it continues from the odometry. But the robot was already in a position before. So what I do is to apply this motion to the previous position of the robot. So I could do this. It's not happy. Does it make sense? Motion is the motion as if the robot was in the origin. But its origin is the previous position. Okay? That would work. Would work, but we wouldn't be caring at all about collisions. Do we like it? So. But right now, let me implement very quickly a draw function so that we can, and some instrumentation of the main, so that we can play with the system. Okay?
Pose is that from word item.
Yes, exactly. Pose is the old variable. Remember that this object here belongs to word item. Let me once again compile it. Do I have you or? Yes. Link libraries, I have to put robot, search, robot. Clearly it compiles. I have to instrument the word, to go back to the word.cpp, and to say that the draw function draws every object. Does it make sense? And I presumably will have to do the very same for the time tick. So far, so good. Then, pardon me, because I will do things that I didn't explain display new, but I have, because to implement the draw, I will have to hack a matrix of OpenCV, but it's not a drama. Void draw draw. Time tick. It's a good thing to say that this function overrides, because this function here overrides the function time tick of the base class. And also the draw will override the function time tick. It works also without the clause override. Works also without the clause override, but with override you make it explicit. And the compiler checks that in the base class there is a function draw to be overridden in the generation of the code. Now, for draw, what do we have to do to draw a robot? We have to draw a circle, right? We have to draw a circle. How big should be the circle in pixels? We have to calculate how many pixels it takes based on the resolution of the map. No? So is radius times inverse resolution, the number of pixels. Okay? Int radius uguale a times inverse. And then we will have to draw a circle into the image by making black all the pixels around the position pose. But in order to find out the position pose, we have to find, based on the pose, where it's located in the map. So we'll have to express also the pose in pixels. Agreed? How do we do? Was word to grid? 2? No. 2? No. How did I call the function? Word.h. Word to grid. Word to grid, no? 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 2, pose.translation. Make sense? And I have the position in pixels. At this point, I have to draw a circle by making black all the pixels in the circle. But I can brutally copy the function collides, because the function collides will just doing the check, which is what I will be doing. Collides. Yeah, copy all and then edit. Okay, R2 is radius per radius, so R2 times equal R2, so that we have this. Return, if not inside P, this was Px, and then we call it P, not to read or to write. Return and basta. If it's outside the map, we don't do anything. And then we have this, off. P test is fine. Not inside return, but we don't return. Let's draw it anyway. If it's not inside the point here, I'm drawing the circle. If it's inside the point, what do we do? It's the only drawing of the circle that we need to do. Done. If the point is inside, what do? We make a pixel black. So display image, I think, dot at 8 row and columns, I think, equals 0. We've done the draw function. Okay. We're happy? I would say so. Let's now put a robot in our world. So it has a function at the Shivu matrix image, and you have to specify which data type because you are accessing. I mean, tomorrow we will understand what these brackets mean. Tomorrow in the lesson time frame. All right. Then put a robot and show see the word the universe crashing. Open COSO. Here we have all these nice things: collisions, word V, load from image. This we don't need. We don't need. We blast everything. Blasted. Just like I copied at the end of the file so that it doesn't bug me. Also, this is to be blasted. Or candidate for blasting. And then we have the funky word. We load it from an image. Very good. The draw function of the word, what is the draw function doing? Nothing. It does just side effect on the... do I have him show? No, I don't have him show. Very good. The word, draw function of the word doesn't do anything. Very good. Robot. And then we would like just to put the robot in the middle of the word because otherwise we don't understand anything, right? Okay. We load the word has a certain resolution, but in order to put it in the middle of the word, we have to calculate in the middle of the image in pixels, and then to express these pixels in a pose. Agree? And this makes me thinking that I might also make the interface nicer and remove the pointers from the signatures and then only pass the references. This way I would have delegated the memory management to someone else. But for now, V and pause. Pose. Robot. Pose. Robot. Is equal to this. Because I have to pass a pose. No? But the constructor required also a radius, right? Yeah, right. A radius. Yes, a radius. Yes, the first variable. No. Coso.cpp. Well, let's make a robot of half a meter. Okay, V and robot pose. But is there a robot.h? Either we do robot.h or we are animals. What do we want? Animal? Ognuno. Time tick. Tick. This was obvious. I called a function that was like items as a function time tick of dt, not time tick without a. Display image was not declared. You are right, man. Display image is not a member of the word item, so I have to extract word item from the so I have to say that this is word, no, a word item, and one of these has a word item as a variable. No, it's like I'm into the robot, I'm not into the word. And the word is the one having, if you look at the variables, yes, there is this CV math here. I will warn you that this program will do nothing, but let's see if it crashes. Inside, why inside? Word inside. Fine. Then we have to execute it, presumably. No. Build. Coso. Dot test data. Or this. Close, but it does nothing. Why? I didn't display anything, right? I have to display something. Now I'm just writing in the OpenCV matrix. In order to display something, I mean, this is a little far-fetched, but I have to do it. We have to show an image. No. Non possono cagare cazzo in questo. Cioè, streaming. Block number. Non è che dobbiamo fare una funzione, dobbiamo chiamare. Però adesso, it's like your colleague asks, but didn't we do the function before for showing the things? That was a little bit hard. Now I change the logic in one way, that we don't do the showing inside the word. We do the showing inside the main program, because in this way every object can call can write into this matrix that is the same. Every object puts himself into this canvas, and then someone else says, show me the canvas. Map. w.displayImage. Can I do another thing for, just like I do a small spoiler, I copy from the other part, the solved exercise, let's call it this way, simulator spoiler. The while loop, because I don't want to look up all the simulator test.cpp. Yeah, this. Because otherwise I would have to remember all the keys, which number corresponds to which key in OpenCV. Do you understand what I mean? OpenCV, okay, with order. The thing works as follows. Here we have a stupid while loop that draws the word, that calls a time tick. Delay will be delay is in seconds. Waits for 100 milliseconds. So one evolution of the word is 100 milliseconds. We evolve the word, we draw the word. Then we ask, and then we have to show an image. CV show. Oh, I never remember show. I try this. Show map. Okay, what I'm doing here, I have a stupid while one. I evolve the word, I draw the word, and the drawing of the word makes side effect on the display image, on this variable, this canvas where each object is painted. Then I wait for the user to press a key. Okay, and depending on the key, CV has this function over here for reading for a key. Just forget it for now. This function just blocks the display and waits the user to press a key. And meanwhile, it shows all the images which are there. Okay? Understood? And then, depending on the value of the key, I can intercept arrow up, arrow down, arrow right. I have fun in changing the velocity of the robot. Okay, so if I press arrow left, means that I want to rotate positively. I increase the rotational velocity. If I press arrow right, I decrease the rotational velocity. If I press arrow up, I'm increasing the translational. If I press arrow down, I'm decreasing. And if I press space, this is space, space, I stop the robot. Eccolo?
CV is a class of iStream? Or?
No. CV is the namespace of OpenCV. OpenCV is a library, and a library comes with its own namespace. So if I would have written here using namespace CV, I would have not had to use this CV dot here.
Can we write 2 times using namespace?
Yes, we can. But then we might mess up with my math and the math of OpenCV. Okay. But yes, we can. Let's see if it works. Probably not. I mean, there will be bugs. No, it's unavoidable. But the important thing, the game of this lesson is not to not make bugs. It's to find any possible one. Ah. You see? 255, 255, 255. Why 255? Huh? Oh. No. Oh. Is the key? No, it's the key. The key is stupid. Now I expect to see the robot in the middle of the map. I don't, right? Where the mistake might be? The mistake might be first in the conversion of the positions. Okay? Or in the, so what do we do in this case? I go into the robot and I have fun in printing all the pixels of the robot. No? Make sense? If word inside of continue. Dust. And then let's see if I made some other mistake in the function draw. What's CPP? Draw copies from grid to display image data, all the data, and calls draw on all members, right? So let's see if the draw of the robot is called. But I will see it because I will see a stream of this p-test over here. And another thing that I will be doing is to, in the coso.cpp, I will just say that I delay 0. If I say that I delay 0, means that the system will block and it will wait me for pressing a key. Okay? If I say delay 0, it will stop until I press a key so that I can see anything that is painted. What do you want? Chair? Oh, you didn't declare CR. No? This is a read-only buffer. But didn't they have robot CPP? I reopen it. Oh. Okay. Not really nice, right? Look at the it prints only one pixel. I expect it to print many pixels, right? Correct? There must be a problem. Let's see where is the problem. Maybe the radius is wrong. The int radius. We said, oh, radius equal radius when we draw inverse resolution. Let's print R2. And then let's also print the int point, the origin of the point. Which should be the middle of the map in pixels. Ooh. Origin 1493, blah, 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 blah. Might make sense. I will now print also the size of the word because otherwise I don't find it. And R2 is equal to 10. 10 is 10 correct? Yes, because we said half a meter and the resolution is 5 centimeters. So this is correct. So there might be an issue somewhere else in here. P-test, but I'm printing P-test, right? Minus, minus radius, radius. Here is the mistake. Look which variable I'm using. Eh? Better. Better, right? And then we replace radius by int radius. Consider that many mistakes we do. I was like basically looping on radius, and radius was 0.1, 0.5. So that wouldn't work. And we expect to see a big ball. Do we? Oh yeah. At least it seems to draw stuff. But I don't see yet anything on the screen. No, I have to press here. I should see a ball somewhere in the middle. So like another mistake that I could have made is in the conversion of coordinates, right? So let me see if I'm really picking with the point at the middle of the image. Okay? Or let me see if I made some other mistake. It may be in the main, because we never have to underestimate the number of mistakes that we make when we operate on the main. Like when sometimes we do mistakes in the test program more than in the test program that we're working on. So, now this was a simple simulator test that I killed. I mean, the ugly thing is that now I changed the keyboard, right? Before I was using my external keyboard, and of the keys that I'm pressing, I don't recognize anyone. So that's why certain things are a pain, because OpenCV just returns you the key codes, which depends sometimes on the device. So we don't need this. We just need the origin. Did I delete the CR inside? Yes. The size of the image. Also. Image size. Why are you printing me these things? Because I don't have a print inside the circle, do I? Do you see a print here? Yes, you see a print. I don't want to have these additional things. Okay, image size makes sense. So the coordinates are fine. So must be some issue, and I'm sure that the image is written. Am I sure? Both. Is it written in the right order? Is it displayed in the right order? I mean, not fond of using libraries that I didn't write. Okay. We do the animals, and we put the InShow inside the draw. Items draw. Be well behaved. This should show himself. I should see a ball. Or maybe we need to make a bigger rock. What do you want? We copy into the data of display image the grid. Oh. Nothing. Do you see anything? No. But let's make a huge robot of a huge radius, at least, you know. A robot of 10 meters, what do you think? 10 meters of robot. Should be able to see it. What? Dici? Or maybe I made a mistake in robot. Let's see. No. Malloc assertion, R2 40,000, origin. Probably I go out of the map. But if I go out of the map, I should spot it because I have the function is inside that should protect me when I go outside of the map. So this might mean that the function is inside is somehow wrong. No? So we started with GDB. Vhere, where did you crash? I crashed. Malign POSIX string. Word draw. Okay. And in ImShow. It crashed in ImShow. You see it? And where the error could be, yes, I mean, we will see in ImShow, but how can it crash in ImShow? Where it crashed. Memaline, morte, malloc assert, malloc.
Però c'era su InShow c'era il primo parametro del massimo, se non sbaglio,
Secondo me non è, secondo me non compilerebbe altrimenti. Il vostro collega dice su ImShow ci stavano due parametri.
Noi gli abbiamo fatto map e poi gli abbiamo passato word
display image. Questo deve fare. No, the problem is like I made the robot 10 meters of 10 meters and it doesn't work. And I mean, now but float radius equal radius is passed. The problem is in here because it starts to paint the stuff, but then if word inside ptest, this should not, if I'm outside of the word, it should not allow me to do this. So it's clearly I'm going outside of the word. I mean, another hypothesis is that word, what? Nah. I think that the robot is entirely, a 10-meter robot is entirely contained in the thing. I mean, let's try with a 5-meter robot. Huh?
Can we display image on data?
No. Ah, what do you mean?
When you call in show.
The draw of the word? Draw, yes.
Yes.
I copy the grid into the data of display image, and this is what I was doing before. Then I go through all items, and I call the draw function, and then into this display image that I've rendered, all objects have drawn themselves, I say OpenCV show these objects. So, there's something odd over here, right? Now we start seeing something, a huge square, and Due? Okay. I start suspecting that it's a fault of the way I use OpenCV that I declared at the very beginning, right? Where was it? Robot.cpp. Display image at 8RC. Let's see in the good one. In the other one. Spoiler. Of course. Makes sense. If not word is inside P. No, seems. Huh? Yes?
Should we have two? No,
if offset by offset, offset is RC, which goes between minus in radius to plus in radius, right? There is the offset. If offset by offset is greater than R2, which makes sense because R2 is my. Yes. Found a mistake. Because I was working with a quad to the power of 4 radius. Bug. Where are you? Here. Oh, la. But it puts this object over here. And this is a problem, and also on the other side. Yes, we start seeing a circle, and let's see if I made a mistake. This is the other robot draw. Let's see if I made a. I told you, like. So P is the origin, and it's fine. In point RC, P test. You see the mistake? P test dot R P test dot C. The test. And then we see mistake. And once again, copy ptest.x. Ptest.y. Yeah, because before I was just like working on RNC happily without I mean, once again, copy paste is evil. Every time you copy paste, you make a mistake. Now let's see if we can move this bastard and then but presume, oh, the robot is where it belongs. Let's move it. Okay, we're moving our gigantic 10 meters robot. Now, I would like to continue, but I think, I mean, what you can do as exercise for the last time, this you can really do it, is to implement a collide function. That, if it's like the game of, do I have 2 minutes? Or there is Scaldapane already warming up? Eh? Okay. La volta scorsa mi ha fatto aspettare, mi vendico. Volete che me... oppure... Dai, mettiamoci la collide. Anzi, esercizio, ce la fate a mettere la collide. So, exercise. Would you like to put the collide? Would you like to put the collide ball... next. Pose. The collide is easy. Next pose is equal to pose times motion. Then we can... Understand what I'm doing? I'm checking, I'm calculating the next position. I'm checking, I will do a collide in the next position. If it doesn't collide by the radius, if it doesn't collide, I just say that the motion should not be updated. This I copy. And then let's make the robot a little bit smaller in the test later. No. Collides IP dot collides P. Oh. Done. Let's try. Oh, radius of 1 meter. Oh, come on, come on. Huh? Okay. Let's move in. Of course, I don't have a theta. Now I'm moving on a circle because I have a rotational. That's the word. Well, of course, I'm evolving at dt of 0.1. So the check is as accurate as the velocity. If I will increase the dt, I will have a higher resolution. Okay, now this is where we went. The next time we put the LiDAR into the system. You like? I have to close the streaming. I didn't curse that much, so I'm happy.